Hi, my name is Shashank and today we are going to understand about robotics. So, the topics which we are going to cover today is introduction to robotics, then what is robotics, what is a robot, the need of robots, first robot used in the history, then we'll see some of the robotic application and we'll focus on line follower robot. Also, we'll put some light on future of robotics. Now, what is a robot? So, this is the most common term which we have heard from a few decades. So, moreover, a specific definition for the robotics, we can see that a robot is an electromechanical machine which is reprogrammable and it is basically most over time used for automatic industrial machine, or it is used to designed to perform some of the hazardous tasks for the humans. So this is quite difficult definition for a robot. So we'll see it in a much easier way. So we can say it a robot is a machine which actually help human in solving their complex works, right? It actually reduces human efforts. It's more over kind of a machine. Okay, and also the one thing is we can program a robot as per our needs, right? So we don't have to do a repetitive work again and again. So that work is being done by a robot. Now, what is robotics? We have heard the term robot. Now, what is robotics? So, robotics is moreover the study of robots, we can call it. So, in robotics, there are multiple fields. There are like multiple departments. There is multiple types of robots, right? So, for that, there is complete stream, or we can say a complete branch is there, that is called robotics. Now, we'll study the definition. So, definition says it is a science of designing and building robots for specific applications. So, simply, as I told you, that robotics is a study of robot. So, for building a robot, there are multiple things are involved and multiple technologies are also involved. So, if in case you want to design a robots, so if you have to know about programming, you have to know about the mechanical structure, you have to know about the electronics, right? So there are like multiple things are there for building a robot, right? Now let's understand that what's the need of a robots. So for a robot, it should be like more precise and consistent than human works, right? Then robots are allowed for increase in production and profit margin because they can complete the task faster. Robots have the ability to work around the clock since they do not require vacations. Robots make fewer mistakes compared to humans, saving a lot of time. Also, robot eliminates the dangerous job for humans, such as like working in a mine, going underwater, going for space exploration. So there are like hundreds and thousands of examples why we need robots, and maybe you will also have a lot of them. Now we'll study some of them. It's more of a kind of application also, and the need also for the robotics part. So first of all, to perform the inaccessible task. So inaccessible task, again, if you want to go underwater, a deep underwater where human cannot go, maybe there is a deep or a huge water pressure, then it can be dangerous also. So if you want to go much deeper inside the water, so we can send a robot will go under the water, study the applications, study whatever we want to do for our research. Then the same case we can consider for space also. We can send a robot for space exploration. So here we can see an image of two different kinds of robots. First one is for the underwater research and exploration, and the second one you can see as a Mars rover which is on the surface of Mars. So as of now, humans are not going to Mars. They have just landed till moon. So to do the research, to do the exploration, we can send a robot to the Mars. Now the second is dangerous and repetitive task. So there is like you can see here there's a robot assembly for building a car or automobile process. You can see here. So here you can see if this work was done by a lot of humans, it would definitely would have taken a lot of time, and there could be some kind of errors also because humans are involved. But in case of machines, or but in case of robots, you can see everything is precise, and programmed, and now that work is completely taken care by the robots. Now, the second thing which we can see here on the next is machine component feeding through a conveyor belt. So it is pretty much common in the industries. You have seen a lot of conveyor belts around the industry where people are like using it, and if we are manufacturing or building something, so it will move from one department to another with the help of conveyor belt. So basically it is again reducing the human work. Now the next field is like wild photography and medical field, we can see. So here you can see the two different kinds of robots. One, you can see a robot that's a photography robot. So here it is a wheeled robot which is being fitted with a camera. So for example, if we are doing a wildlife photography, there is always a danger of life when you are shooting the wild animals. There could be a chance of attack, so it would be much better if we can use a robot over there, put a camera. If a animal wants to attack, so they will attack on a non-living thing, that is on a robot. But if a human will go to that place, then definitely it can cost a life. So we'll now see the second one, that is in the medical field. So in the medical field, you can see a machine over there that is called Da Vinci machine. So this is a machine which can perform different kind of surgical operations, and that do not require any human efforts, right? So for example, if you are sitting in a remote place and you have to operate a person, so while sitting on a remote place, you can get all the functionality, all the movements of this machine. Then whatever action you will perform from that remote location, the robot will perform the same thing at the hospital. So let me give you an example. So it's a true situation. There was a patient in Chennai AIMS, and it has to perform open heart surgery for a patient which was very critical, and the doctor was coming from Singapore. Now there was an issue of time because his flight was like more than 3 hours of delay, so they need to perform the surgery at a very fast pace. So what doctor has done, he was sitting in Singapore, he was operating that Da Vinci machine from Singapore, and that open heart surgery was automatically being performed in Chennai AIMS. And at the result, the patient was successfully saved. So it's a very major application in the field of medicine. Then a few more examples are there. You can see here there is one more robot which is moving around the intestine, looking out for any kind of tumors or any kind of problem inside your stomach. Then the next, you can see there is an exoskeleton, you can say an arm, you can say a robotic arm, you can see here, right? There's an artificial limb which is attached to the human. So that is also one of the major application. Also you can see there are minor robots also which can actually move inside the inject, or they can be a biological robots which can inject inside the blood and can work with your blood cells also. Now there is a field called military and defense. So mostly that is one of the place where there's a huge chance or huge risk of life. The soldiers are fighting whenever there is a terrorist attack or there is a war situation between the two countries. So if humans or our armed forces are directly involved in these things, so there could be a chance of life danger. So for that cases, nowadays there are a lot of robotic machines or drones are being used, or humanless or with no pilots, aircrafts are also there, and artificial bombing airplanes are also there. So that is what robots are playing a major role in the field of military and defense. Now let's understand when was the first robot officially used. And if I have to tell you the history of robots, so robots are being used from a very long time, not now. It's been in 10th BC, you can say in 10th BC the robots was used for the very first time. Now you will shock, okay, how is it possible in 10th BC a robot can be used, right? So it was like a toy, okay, it was like a toy made like a human, and mechanically it was making some action, right? Mechanically it was making some action. So it was, although we cannot say it we can program it, but yes, manually we can control it. So technically robots are being used from a very longer period, but officially if we have to say, the first digitally operated and programmable robot, its name was Unimate, and it was installed in 1961 to lift hot pieces of metal from die casting machine and stack them together, right? So you can see the image of this particular robot Unimate over here on the screen. Now the fully autonomous robot will understand later on the types of robots. So fully autonomous robots means which do not require any humans, like it can operate on its own. That appeared in the second half of the 20th century, right? Okay, now we'll understand about a line follower robot. So before going to this section, first of all we should understand what are the types of robots, right? So there could be there will be different types of robot. Moreover, if I'll have to tell you in a broader way, so basically the three types. The first one is the manual robots. Second is semi-autonomous robot. The third is autonomous robot. By the name itself, manual robots are those robots which need to be controlled manually, either with the help of a remote or with the help of some kind of mechanical actions. So let's take an example of a manual control robot, a manual drone which we need to fly from our hand with the help of a remote, wireless remote, or a remote control car also. That is an example of a manual robot. Now let's come to the semi-autonomous robots. Semi-autonomous robots are those robots which are programmable also, and it can be manually controlled also. Okay, so semi-autonomous robots are like your line follower robot. Basically we have designed a robot which performs a particular action, but it is still limited, means we still need to give directions. So for a line follower robot is an autonomous robot which follows either black line or a white line. So we have programmed this robot to follow a particular line. Now the line need to be designed by ourselves. Means a robot, if you put it on a particular complete white surface or completely different surface, it will not be able to perform any movement. Maybe either if it is moving also, it will move here and there, will not serve the purpose, right? So for that reason this is called a semi-autonomous robot. Means it is already programmed, means whenever it will detect some particular color, let's say in our case a black color or a white color, it will take the necessary turn or the actions. But in case if we don't provide that particular line or color, it will not be able to take those action at that moment, right? So this is an example of a semi-autonomous robot. Now let's come to the autonomous robot. What are autonomous robots? So autonomous robots are those robots which are completely automatic, means which do not involve any kind of manual action. They are smart enough to take actions on their own, right? They don't want any kind of manual control or a manual suggestion. They learn on their own self. So we know about a technology called artificial intelligence or machine learning, right? So using machine learning algorithms, using artificial intelligence, we design such robots, we program them so that it can understand different scenarios and it can take appropriate actions accordingly. Means we don't have to program it again and again, or we don't have to operate it manually. So it will be able to distinguish between 2 to 3 different scenarios, or even it can be more in some cases. So let's take some examples. We all have seen a robot called Sophia. We have seen a lot of humanoid robot, and to be more precise, we all have seen the movie called Robot by Rajnikant. There you have seen an autonomous robot which was having the capabilities to think, which was having a capability to perform certain actions which were like programmed inside it, and it was like able to learn from its action or from the people who were performing certain actions. Now there are a lot of companies in the market which are right now doing or building these kinds of robots from a very very long time. Okay, now moving further, we'll see how a robot work, and we always keep this line follower robot in our mind. So for example, if we want to build a robot, right, or if we want to build any machine, so we need to follow a certain process. So in our case the process will be like this. A robot is same like a human. We have to understand in this way, a robot is same like a human, as we have our sensory organs from which we sense the environment. Then as soon as we sense the environment, those signals or those messages are being sent to our brain, and then our brain is having some sets of action, is like able to process whatever we have like felt or whatever we have understood. Then it takes some necessary actions accordingly. Let me give you an example. Let's say if we are if there is a fire at some place and we are nearby to that fire, what will happen? Our skin will feel the warmth, or our skin will feel that fire, skin will see that warmness of the fire. Then it will send a signal to our brain, and we already know, our brain will instruct this is dangerous, you have to come back, so we'll automatically move back, right? And how this thing happened? Because since we were a child, right, our parents, our teachers, and by ourselves also, right, so whenever we have like went through this kind of situation, we always came back, right? So we have a capability of self learning also. People around us have taught that these things are dangerous or these things are good, right? So this is how human works. Same way, whenever we are designing our robots, they also work in the same process. They require an input system, or in the terms of robotics or machines, we can call them as a sensors. Then a processing system or a processing unit, that is a brain of a robot. So it will be a microcontroller. Now input is there, processing is there. Now there is a time for an output. So output would be mechanical, because we are using a robot over here. So it's a mechanical, it's a hardware based device. So we require actuators, right? Actuators, or we can say in a layman language, motors, or we can say as like in the mechanical parts or movement parts, leg or something like that of robot, right? So these three things will be used. Now our human body has different sensory organs. So let's list some of them. The first one is our eyes, from which we are right now watching the entire video. Second, we have ears to hear. Then we have nose to smell. Then we have our skin to touch. Then we have our tongue to taste, right? So there are like different sensory organs we have. Same way, our robot is also having these kind of sensory organs. So these are like sensors. They are called as sensors. Sensors are a device which converts the physical surroundings into electrical voltages, electrical signals, right? So if we get any kind of electrical signals, we can process it, right? So similarly, for eyes, there is a sensor called IR sensor, or we can use a camera. Then for smell, we have smell sensors. For touch, we have like touch sensors also, which we have all seen in our mobile phones. Then for for hearing, we have microphone, right? So similarly, like for the robots also, there are a lot of sensors, lot of input devices. Now here in our line follower robot, we can see there is an IR sensor in front of you, there is an LED. So we'll study about the sensors later in some other video. Now we'll come to the second part, which is called the microcontrollers. Now what is microcontroller? Microcontrollers are the devices which processes the instructions received by the input devices, and after processing those instruction it gave an instruction to the output devices, right? So here we can see a small microcontroller over there. Microcontroller is a device which has lot of components inside it, and we can program it as per our need. Okay, so moreover we can say it is like a brain of a robot. Moving further, we'll understand about motors. So motors are same as our hands and legs for the movement or locomotion, right? So in human body we have legs, we have hands for the movement. In robots there are motors are involved mostly, because motors create necessary or certain movements which makes a robot move from one place to another, or to make some kind of changes, some kind of action. Okay, so there are different types of motors for different types of robots depending on the application. For example, if we have an application in which we require a fast movement, or a rapid movement for a robot, will use a different kind of motor. Let's say we can use a DC motor, which is normally used in a wheeled robot. Now if we have a requirement only a hand movement, so we all have seen a robotic arm, and in the example on the applications also I've shown you in the automobile industry, there were robotic arms over there which require a particular degree of movements, right? Particular degree of moments of was required. So for that we can use a stepper motor or a servo motors, right? So different kind of motors are involved for the different purposes. Now we can see a schematic for a robot. So for more specific, if we go, we can see for a line follower robot. So what is actually involved? So there is an input system, then there is a processing system, and there is an output system. You can see there on the screen. And now in the input system we can put a sensor array. So here in our case our sensor is the IR sensor. Now for the processing system we are using a microcontroller. So right now here it is mentioned as 8051. You can use any microcontroller, you can use an Arduino, you can use a Raspberry Pi, you can use an Intel Galileo, or any board depending on your requirement, what kind of robot you are building, you can put it over here. Then on the output system or the actuator system, you can put your motors. To run your motor, here we are using an IC called motor driver. We'll again study these topics in details in some of the other videos. Now the motors are being controlled with the microcontrollers, and here microcontroller is receiving the signals from the sensors, right? So this is the schematic of a line follower robot if we want to build. Now let's see the future of robotics. So there is very huge or very bright future in robotics. If you wish to pursue a career in the field of robotics, it's a huge growing field, and in the today's world of increasing the digital economy era, we have seen a lot of industries are basically now switched to robotics. There is a huge industrial automation going on. We have all have seen the automatic cars, self-driving cars, the drones, the humanless aircrafts. Many things are there. So there is a huge demand of robotics all over the world, especially in the field of research, in the field of healthcare. There is a huge huge growth. So if you want to pursue a career in some of the field like this, you can definitely opt in to learn this particular field. And there is a huge number of demand also there in the market. Many big companies like ABB, Toyota, Samsung, many companies are right now hiring for the robotics engineers. You can be a research and development engineer. Many fields are there. So it's pretty much wide field, and there's a very huge future involved for robotics. And in future maybe we will be surrounded by the robots. So already we will not require a lot of servants and all. We can have our own robots. Thank you so much.